Water is one of Hong Kong's most valuable natural resources. Apart from the hundreds of rivers and streams which network the territory, there is the world-famous Victoria Harbour. These natural sources of water have multiple uses. They are valuable assets of the Hong Kong people. However, Hong Kong people do not treat this natural resource with the respect it deserves. Some restaurants, factories and poultry farms often flush untreated pollutants into rivers or the sea, resulting in serious water pollution. It's been estimated that every person in Hong Kong produces about 300 litres of wastewater daily. This amount is equal to the total capacity of 16 large distilled water dispenser bottles for every person in Hong Kong. There are about 7 million people in the SAR, hence the daily production of wastewater by Hong Kong people is exceptionally large. How are we going to handle this increasingly serious problem of water pollution?
We have developed a comprehensive strategy to cope with the problem of the growing population and increasing burden of water pollution. The sewage treatment strategy is based on a series of water quality objectives, WQOs. These objectives stipulate the maximum amount of pollutants different water bodies should be allowed to carry, as well as the minimum required levels of various components which the water bodies must maintain for their respective uses. There are different objectives for different water bodies, depending on their nature, usage and sensitivity. There are 4 components to the sewage treatment strategy. Control of the sources of pollutants, collection of sewage, treatment and discharge, and finally water quality monitoring and function testing.
The control of sources of pollutants is achieved through legislative means and makes use of the executive arm of government for enforcement. The aim is to control the quality of sewage from different sources, including restaurants, factories and farms, and to ensure that the sewage is delivered to a proper treatment system. The legislature has instituted measures to ensure that no untreated sewage is discharged into the environment. The Building Ordinance and Water Pollution Control Ordinance place responsibility on the discharger of the sewage for proper maintenance of the sewage collection system. The discharger has to eliminate all particles like solid matter and grease which can block public sewers, as well as any excess materials that the sewage treatment plants cannot deal with. Meanwhile, the discharger also has to ensure that sewage outlets are connected to the nearest public sewers. The Waste Disposal Chemical Waste Regulation states that all chemical wastes have to be properly wrapped, labelled, stored and collected by authorised collectors and properly delivered to authorised chemical waste treatment facilities for disposal. The Waste Disposal Livestock Waste Regulation ensures that poultry farming can only be operated in designated areas, and that any waste collection and disposal resulting from poultry farming has to be done according to established standards. To enable sewage to be delivered to appropriate treatment plants, we need to have a proper sewage collection system. At present, over 95% of Hong Kong households are connected to the public sewerage system. Only about 2% of the sewage produced in Hong Kong is untreated and discharged into the sea. As early as the late 1980s, the government had already implemented a comprehensive improvement project entitled the Sewerage Master Plan. The purpose of the plan is to ensure that all the sewage in the SAR is properly treated before discharge. Following the plan, the SAR was divided into 16 catchment areas. Improvement and renewal work is carried out on a catchment-by-catchment basis to upgrade the overall effectiveness of the existing sewerage system. This work includes the construction of new sewage treatment facilities and the extension of existing sewage treatment plants. In addition, the network of sewers is being extended and pipe laying is being conducted to bring some remote villages into the network. In some factory areas or in districts with many restaurants, there is often serious blockage in the sewers caused by huge amounts of garbage and grease being discharged. The Drainage Services Department has therefore set up a precautionary maintenance procedure with regular checkups on the entire sewer network to ensure free flow at all times. Presently in Hong Kong, sewage is drained via sewers, whereas rainwater runoff is drained via rainwater drains. However, in planning the sewerage facilities, we often encounter difficulties like these.
There are no sewers in some districts. Some sewers are too small and cannot accommodate the increasing amount of sewage produced. Some old sewers are worn out, causing sewage to be discharged into the rainwater drains. As the roads in Hong Kong are congested with people and vehicles, any construction or maintenance of sewers where road excavation is required will result in serious traffic jams and inconvenience to the public.
To solve these problems, the government has implemented a number of sewage collection plans.
Building new sewers in rural and new development areas, increasing the capacity of sewerage facilities, repairing or renewing old sewers and intercepting sewage which has leaked into the rainwater drains, making use of new trenchless pipe laying installation methods to construct new sewers in congested districts so as to minimize the effect on the environment and on traffic.
Every day in Hong Kong, as much as 2.2 million cubic meters of sewage, enough to fill 1,200 standard Olympic-sized swimming pools, is sent to the treatment plant in each district for processing. Sewage treatment in Hong Kong is generally divided into 4 levels: preliminary treatment, primary treatment, chemically enhanced primary treatment, and secondary treatment. Most sewage screening plants in the urban areas were built in the 1960s. They are responsible for preliminary treatment of sewage in the respective districts. Preliminary treatment consists of screening and removing from the sewage any sand particles exceeding 2.5 millimeters in diameter and any suspended solid particles exceeding 6 millimeters. At present, about 60% of sewage is discharged into the sea after this preliminary treatment. After preliminary treatment, that is, when sand particles and suspended solid particles exceeding 6 millimeters in diameter have been removed from the sewage, it is allowed a longer time for settlement. This allows the suspended solid particles of smaller size to also be filtered away. When this has been done, the sewage will have reached the primary treatment standard. About 1.5 million cubic meters of sewage is discharged into Victoria Harbour daily. To improve the water quality of the harbour and to meet the increasing demand of the growing population, the government is working on a huge sewage discharge scheme. This involves the use of tunnels deep underground to collect sewage from both sides of the harbour and deliver it to the centralised treatment works on Stonecutters Island. This is the Stonecutters Island Treatment Works. The daily amount of sewage treated here is the highest in the world among treatment plants of a similar scale. Sewage collected from both sides of the harbour, after being treated by screening plants in each district, would be delivered to the Stonecutters Island Treatment Works for chemically enhanced primary treatment. The sewage is pumped up to surface level from pipes over 100 metres underground. On the surface, it is mixed with appropriate amounts of ferric chloride and polymer. The resulting chemical reaction will make the suspended particles coagulate into larger solid particles which will settle to the bottom of the pool. The settled sludge will then be separated by machines. Finally, treated sewage will be discharged through openings into the sea. The treatment at Stonecutters Island Treatment Works will clear up to 80% of suspended particles and 70% of biochemical oxygen from the sewage. In other words, sewage treated in this way is much cleaner than that processed by preliminary treatment only. Chemical enhanced primary treatment is 50% cheaper than secondary treatment. Coupled with the natural purification which takes place in the ocean, chemically enhanced primary treatment is a cost-effective method of sewage treatment which has less impact on the environment. Most new towns are equipped with modern biological treatment plants, which are commonly known as secondary treatment plants. About 20% of the sewage in the SAR undergoes this biological treatment. After initial screening, the sewage is allowed to settle, after which small suspended particles are removed. The sewage then flows into aeration tanks. The microorganisms then digest the organic matter in the sewage. Pressurized air is pumped continuously into these tanks to sustain the growth of microorganisms. The biologically treated sewage is then discharged into rivers and inland water zones after disinfection. Just like any other public service, sewage treatment facilities have to be periodically renewed and regularly maintained in order to optimize the functioning of the system. In the past, all sewerage service expenses were borne by the government. However, with the development of numerous drainage improvement projects in recent years, as well as the increasing cost of operating and maintaining various sewerage facilities, the government had to implement the sewage charging scheme in April 1995. Based on the principle of the polluter pays, the sewage charge is collected to cover the daily operation and maintenance of sewerage services. Other capital construction costs and expenses are still borne by the government. Do you think the government should collect sewage charges? To safeguard the quality of water on our beaches, the government has set up a Water Quality Objective, or WQO, under the Water Pollution Control Ordinance. This objective focuses on the density of E. coli in seawater samples collected from March to October each year. The geometric mean of the density of E. coli in the water samples should not exceed 180 per 100 millilitres of seawater. This objective is applicable to all beaches within Hong Kong waters. To protect public health and evaluate the water quality of beaches, the Environmental Protection Department has implemented a comprehensive beach monitoring program. The program has the following 6 functions: to provide information to relevant authorities to assess compliance with WQO, to detect any trend towards change in the beach water quality, to identify polluted beaches where remedial action is needed, to evaluate the effectiveness of pollution abatement measures such as newly constructed sewerage facilities and relevant legislation, to advise the Beach Authority on long-term development trends in beach water quality, and to provide updated information to the public on the current status of beach water quality. The beach monitoring program includes the collection of beach water samples, laboratory analysis, and data management. How do you extract samples?
We collect water samples at a depth of from 0.6 to 1.0 meters. That is between the thigh and the waist of someone standing in the water.
What kind of test will you conduct in situ?
We will measure the water temperature and dissolved oxygen concentration in situ. We will also record the condition of the beach and the weather conditions.
How do you conduct the other tests?
The water samples will be sent to the laboratory for testing and will be kept at about 4 degrees Celsius during transportation.
What kind of tests will be carried out at the laboratory?
Physical measurements like analysis of E. coli density, pH, salinity and turbidity.
Why is analysis of E. coli density necessary?
Beach water quality monitoring is based on the measurement of E. coli density, which is the microbiological parameter stipulated in the WQO. It is an internationally accepted standard.
So what is the reference value of the WQO based on the parameter of E. coli density?
Based on the geometric mean of E. coli density, all beaches in Hong Kong will be classified into ranks.
It is understood that rainfall is one of the main factors affecting the water quality of beaches.
Heavy rain will cause sewage to overflow from septic tanks or bypass the interceptors. This will increase the polluted surface runoffs in the beach hinterland. The water quality of the beaches therefore usually deteriorates after heavy rains. The time taken for each beach to resume normal quality varies. Most beaches can generally do so within 3 days of the rain stopping. The EPD has therefore advised the public not to swim during or within 3 days of the end of the rainy periods. Before swimming, the public may wish to check for the latest information on the notice boards at the beaches. When there is a pollution incident which might jeopardize the suitability of the beach for swimming, the government will decide if it is necessary to close the affected beach temporarily for the benefit of the public.
Different monitoring systems and water quality objectives have been developed for water in rivers, streams and the sea. The EPD has a scientific vessel, the Dr. Catherine Lamb, which is responsible for monitoring seawater. The vessel is equipped with a global positioning system for accurate location of sampling stations at sea. There is also advanced equipment on board which can measure and record physical and chemical parameters ranging from water depth, water temperature, pH, salinity and turbidity to dissolved oxygen amount. The data will be input into the computer system immediately. The EPD will also collect seawater and sediment samples for analysis against some 40 parameters, including nutrients, metals, organics and coliform bacteria. Through these analyses, we can assess if the standard laid down by the WQOs is being maintained.